Hello, and welcome as we start this new section on advanced DNS, CDN, and failover networking. In this particular lesson, we are going to focus on learning about Amazon Route 53. So over here in the Orion papers, let's drill down into our region, availability zones, show our VPC networking, and then click on Route 53. Also, over here in the AWS console, you can find Route 53 under networking and content delivery right here. So first, let's understand the basics about Route 53. So Route 53 is a domain management service or a DNS hosting solution provided by AWS. It has three key features that we should discuss. First is domain registration. You can register domain names such as orionpapers.com through this particular service. It also has a domain name system service, and this translates friendly domain names like www.orionpapers.com into IP addresses like 192.0.2.1. Amazon Route 53 responds to DNS queries using a global network of authoritative DNS servers, which reduces latency. Also, health checking. So Amazon Route 53 sends automated requests over the internet to your application to verify that it is reachable, available, and functional. So some other key points about Route 53 that we should be aware of is that Route 53 can manage external DNS for domain routing, meaning routing requests for orionpapers.com to proper AWS resources such as CloudFront distributions, Elastic Load Balancers, EC2 instances, and even RDS servers. Route 53 is commonly used with an Elastic Load Balancer to direct traffic from the domain to the Elastic Load Balancer and thus have traffic evenly distributed among servers running your application. Route 53 can also be used to manage internal DNS for custom internal host names within a VPC as long as the VPC is configured for it. Also, latency, geo, basic, and failover routing policies allow for region-to-region fault-tolerant architecture design. You can also easily configure for failover to S3 if website bucket hosting is enabled, or also to CloudFront. So let's back out of here for a second and again just look at our diagram and understand what is happening here. So when a customer types in www.orionpapers.com, or if you type in www.linuxacademy.com, what Route 53 does is Route 53 takes that request and it says, okay, for www.orionpapers.com, where should I send that traffic? Should I send it to an Elastic Load Balancer? Should I send it to a specific EC2 instance? Should I send it to an S3 bucket? Should I send it to a CloudFront distribution? So it is making the decisions of where the traffic should go when a customer puts the request into the browser for a specific domain. So it's translating the domain name to an IP address or to an endpoint within AWS. So we can do things like take the Elastic Load Balancer, which we have provisioned in our VPC that distributes traffic evenly between our EC2 instances, and we can have Route 53 take www.orionpapers.com and point it to the Elastic Load Balancer so that when somebody inputs orionpapers.com, the traffic comes through and it sends it into the VPC to the Elastic Load Balancer. Then the Elastic Load Balancer will distribute the traffic between the various EC2 instances that are running the application. So jumping back into Route 53, let's now move on to hosted zones. So we see over here that we have hosted zones. If I click on a hosted zone here, we see that I already have one set up. Now I've already gone ahead and registered orionpapers.com with AWS. And if you want to see a full walkthrough on how to register a domain with AWS, you can go back and view that lecture as part of the AWS Essentials course that is here on linuxacademy.com. However, at this point, we will assume that you know how to register a domain with AWS, so we'll start here with the hosted zone. So a hosted zone stores DNS records for your domain. Basically, it contains all the rules, meaning the record sets, that tells Route 53 what to do with DNS requests. There are both public and private hosted zones. So a public hosted zone is a container that holds information about how you want to route traffic on the internet for a domain, such as linuxacademy.com and its subdomains. A private hosted zone is a container that holds information about how you want to route traffic for a domain and its subdomains within one or more virtual private clouds. So now after you create a hosted zone for your domain, such as orionpapers.com, you create resource record sets that tell the domain name system how you want traffic to be routed for the domain. And hosted zones come pre-populated with NS, meaning name server, and SOA, start of authority, record sets already created for you. So I just registered orionpapers.com with Route 53 in my particular account. And if I click on this, and again, this is a public hosted zone, but it came with 2 record sets already created for me. So it came with the NS and the SOA record sets created for us, which handles a lot of the nitty gritty backend DNS work. So we can go about now creating our custom DNS records to point the web domain to specific endpoints within AWS. So how do we go about doing that? Well, that's where record sets come into play. So record sets are instructions that actually match domain names to IP addresses. So record sets are comprised of various options, including a record type, standard or alias, routing policy, and also the ability to evaluate target health. So let's take a look over here and let's actually set this up so that the Orion papers will point to my Elastic Load Balancer. So let's go over and take a look at that, because if you remember from earlier lessons in this course, I have an EC2 instance set up, so we can take a look at that. And this particular EC2 instance currently has the Apache web server installed on it. So again, if I just grab the public IP address here and drop it into another tab here, we do see that we are able to access over the open internet the Amazon Linux test page. So now, if I go and look at my Elastic Load Balancer, and I check on instances here, we do see that instance is associated with the Elastic Load Balancer. So if I come back to descriptions here, I can grab this DNS name here and just test this out. I should again get the exact same page. Okay, good, I get the Amazon Linux test page. But anybody outside of my account, meaning any one of my customers, would not have either the public IP address or the DNS name for the Elastic Load Balancer, but what they will have is www.orionpapers.com. And so what I want to do now is I want to enable the ability for my customer to go to my website and have it redirected to the Elastic Load Balancer and be served up the Amazon Linux test page. So if we come back over here to Route 53, I can create a record set. And the first thing that I have to do is establish the name. So this can either be blank, meaning just orionpapers.com, or it can be www.orionpapers.com. And generally what you want to do for best practice is to create 2 record sets, one for just orionpapers.com and then another one for www.orionpapers.com. So now let's talk about type here. So there's several different types that we should know about. Some are more common than others, but the most common are A, AAAA, CNAME, and MX. So a record type of A is used to point a domain to an IPv4 IP address. AAAA is used to point a domain to an IPv6 IP address. CNAME is used to point a host name to another host name, and MX is used to route emails, meaning a mail exchange. So what we're going to do in this particular instance is just use IPv4, meaning that we want a type A record. Next, we have to decide versus standard or alias. So what an alias record is that instead of an IP address, meaning a standard record set, an alias record set contains a pointer to an AWS-specific resource, such as an Elastic Load Balancer, CloudFront distribution, Elastic Beanstalk environment, or an Amazon S3 bucket that is configured for static website. So what I can do here is I can have my domain name pointed directly to a specific IP address. So I could actually take the public IP address of my EC2 instance and have Orion Papers point directly to the EC2 instance. But what happens then if the EC2 instance fails, then my customers are not going to be served a website. So that is not good for high availability and fault tolerance. So what I want to do is I actually want to point it to my Elastic Load Balancer. And I establish that by selecting yes as an alias, clicking here on alias target, and then we see here that my Elastic Load Balancer is currently being offered as an option to use as the endpoint for this particular record set. So I can click on that. Then we have to decide on a routing policy. So let's talk specifically about the various routing policies. They're simple, and that's where we route all traffic to one endpoint. In this instance, we're going to route it to the endpoint of the Elastic Load Balancer, but then the Elastic Load Balancer will distribute it out to many endpoints after that. Weighted means that you can route traffic to multiple endpoints, and this is a way of doing manual load balancing. So I can create several different record sets weighted, and I can actually select the weight for various endpoints. Now, this is a great way that if you are slowly migrating, say, from on-premise to the cloud, you can have 80% still going to your on-premise data center And as you slowly build out your cloud environment, you can have 10, 20, then 30, then 40, then 50% of the traffic going to the cloud environment. So what you can do here is you can really kind of mix and match. And instead of having traffic distributed evenly like on an elastic load balancer, here you can actually set the weight. So you can decide how much traffic you want going to one endpoint over another endpoint. Then there's latency, and this is where we route traffic to an endpoint based on the user's latency to various endpoints. So let's say that you have servers all over the world, and you have a particular user that comes to your website. What it's going to do is it's going to ping all of your various servers or all of your various endpoints, and whichever one returns the least amount of latency for that particular user, then that is the endpoint that it will serve that specific traffic to. Next is failover, and failover is where we can route traffic to a secondary endpoint if the primary is unavailable, and we'll go over that in a little more detail later on in this lesson. Then there's geolocation. This is where you can route traffic to an endpoint based on the geographic location of the user. So let's say that you have a user in England and you have a server in England. Well, you can say specifically for all of my customers that IP address originates in England, serve them to my server that is in England. So you can set specific geolocation restrictions based on where your customers are. And last is health check, and this is just a check where you can have Route 53 monitor the health of your application and trigger an action like you would with our failover routing policy. And we'll review how to set that up momentarily. But now let's go about setting up our Type A record to our elastic load balancer, and we're just going to use a simple policy. So I created one. This is our www record set, so I'll hit create. And then I'm going to do it one more time, but just leave this blank, but click on yes, select the elastic load balancer, leave it as simple, and click create. That's all I have to do. It's that simple. I have now pointed www.orionpapers.com to my elastic load balancer. So now when I go to a browser and I type in www or just orionpapers.com, it should serve up the Linux Academy test page. Now, I'm going to pause the video and wait probably 10 to 15 minutes because these new DNS records do have to propagate out over the internet to other DNS servers, and that can take some time. So I'll pause the video and be right back once that is complete. Okay, I've waited about 15 minutes. Let's open up a new tab and drop in orionpapers.com and see what happens. Awesome. We got the Amazon Linux AMI test page. So again, just to kind of recap what's happening now is that I'm sitting here. This is me, and I'm putting orionpapers.com into my web browser. That traffic is going across the open internet into Route 53. Route 53 is saying, okay, for www.orionpapers.com, what do I do with that request? And it's saying I'm going to now send that to the elastic load balancer inside of the VPC, so that it comes in through the internet gateway to the elastic load balancer, and then the elastic load balancer serves it to the EC2 instance. So that's exactly how all of the routing works now that we have added in Route 53 to the mix here. Now, Route 53, again, can also serve traffic. Instead of serving it into the VPC to an elastic load balancer or to an EC2 instance, it can also send it to an S3 bucket, and it can also send it to CloudFront. So in the next lesson, I will show you how to use an S3 bucket for DNS failover. But for now, we'll conclude this lesson. Thank you for watching. You may now move on.